Now the thickness of the wall decides after how much time that heat will travel into the building. Now, in case you can cut down the time the sunlight falls on the wall, that is the amount of time you have reduced, or the heat that is going to be absorbed by the wall is reduced. That is how you have made your building thermally comfortable. So the first point is, do not shade just your window. You have to shade the complete wall. As in this, I have shown that the angle of sunlight should go right down to the bottom of the wall and not just the window. Yes, during winters, the sun angle is lower, so at that time, it should go through the window and the heat should come inside the building. But during summers, that sunshade should be sufficient to cover the whole of the building. So while designing, it should not be this, that sir, 2 feet wide sunshade is only allowed, or 1 feet 6 inches wide sunshade is only allowed. No, the sunshade has to be as to where your building is being made geographically. And it has to be extended, so maybe 3 feet or 4 feet, depending upon how the sun movement is in that area. So the guidance should be that and not a technical guidance. You can also reduce the sun heat going into the building by simple processes during construction only. People, I've normally seen architects coming, consultants coming and saying, sir, what have you done? Sir, I made a green building. A green building? I have put up puff sheets inside the wall. Sir, heat will not come in. What have you done on the roof? Sir, the air conditioning guy has told me that put a insulation board below the roof. Now, while making the building only, and that guy is at the stage of starting to design the building has not yet come up. Now, while making the building, you can simply design your walls in a way that the heat won't come in. How? In case, over here I've shown you 2 walls. The inner wall has basically a brick pattern is shown, and there is an outer wall. So inner wall you can say is a 9-inch thick wall. This is known as a rat trap bond. What is a rat trap bond? It is basically a 9-inch thick wall only, but it has an interconnected air passages within it in the construction procedure only. It is very simple to make. In fact, it is cheaper to make than a normal 9-inch brick wall. You save around 25% bricks in this while construction. It has more strength than a normal 9-inch brick wall. And you save on the mortar also. So what does the air gap in between do? Air is the real insulator for anything. In any insulation material, you basically divide the air into many parts. And that insulation, that air basically combines into an insulator. Now, again, while making the building, in case you have just made this wall, just alone the rat trap bond only, you will see there will be a reduction of more than 30% of heat coming inside the building, because in a rat trap bond, the area which is now in direct visibility or in contact with the sunlight outside is reduced to around 25% only. So now the whole wall is not carrying the heat inside. It is only 25% of the bricks, which are the flat bricks which are protruding outside. The rest area is not, the inner wall is not in contact with the outer wall. Only the cross wall brick is in contact with the outside. So you have now reduced the amount of heat coming into your building. Again, you can give a 4.5-inch thick wall with a gap of say 2 to 3 inches or 4 inches in between on the outside of that wall. Since you have saved 25% of your bricks, now that is just with a small addition of say 5 to 10%, you can now create a 4.5-inch brickwork outside. So you haven't added your costs or anything. That outside wall will work as a shading for the inside wall. Again, that outside wall will get heated up by the sun. The gap in between, that will heat up the air in between. Now if you see, I've given a small opening in the outside wall at the bottom and at the top. So you can allow the air to travel behind this outside wall and move out. What that air will do, that will take away all the heat along with it and move out. So the inside wall will remain always cold. Your insides are not going to get heated up ever again. You have not used now any of those things, foam and everything. Today outside in many countries you have seen that the whole building burns up very fast. it catches fire and burns up very fast. That is due to the insulation materials. All these insulation materials, maximum of them, catch fire very fast. So in case you have insulated your building from the inside all over and a fire occurs, basically it's really not possible to get out of it. Because any insulation material like puff, thermocol or anything catches fire very fast, and it means the person can get suffocated over there in that. Again, you can insulate the building in case you have seen on the top I have given, with respect to the thickness of the slab, I have given a very large thickness of mud on it. Mud is a very good insulator. In previous days, on the roofs, before the new generation came after the independence, mud was the real insulator in all the buildings. We used to use mud to a larger thicknesses. Those were 9 inches, 12 inches, 15 inches thicknesses. Now these thicknesses basically reduce the amount of heat coming into the building. On the top, at the top level, basically the RCC slab gets heated up. Once it gets heated up, it stores heat inside it. It stores heat inside it. In the evening, even the sun, in case it goes away, no problems. When you go to sleep around, say, 8 or 9 or 10 o'clock in your room, you suddenly feel the heat inside, although the sun is not there. And you immediately want to turn on your AC or the cooler or the fan, or you turn it on faster. And say around 2 or 3 o'clock in the night, you start switching it off, reducing the speed of your fan and everything. That is due to the reason that your walls, your slab, all have absorbed heat during the day. And they are now releasing that heat into the building during the evening time, even when the sun has gone away, because they are working as heat storages. So do not allow them to be heated in the first case only. So putting an insulation inside is of no use when you have allowed the walls and the slab to get heated up. They are going to put pressure on that insulation. The insulation is a costly material. You are going to end up putting up a thinner insulation than what is required. Again, due to the cost, sir, the cost is getting jacked up. You say a green building is very costly to make. It's not costly to make. The cost of mud is not much. I've shown you that brickwork you are saving instead 25%, and again, which you can put outside, the cost is same. It is only understanding how to make that thing before. You can put up, I've shown a green patch on the top of the roof. You can put up a grass over there, or you can put up reflective tiles on top. Again, reflective tiles, say of white color or of white color, reflect light very fast. They reflect away around 60% of the heat themselves only. So below that, in case you have mud, you have insulated the building. As I said before, the 70% of your power consumption in the building is of air conditioning. What is air conditioning doing? It is basically removing all the heat which has been entrapped within the building. You have basically, previously we used to make buildings and then put in a cooler or an air conditioner. Today the concept has gone the other way. Today first it is decided, okay, this building is going to be air conditioned, and then the building is designed for it. You make a closed box of a building, you allow all the heat to come inside it, and then you use an air conditioning machine to take that heat out of that building. I'll just go ahead with certain other procedures through which you can, first I've shown you how you can stop the heat from coming in. Then I will show you how you can remove the heat which still has come in. Over here I'm just showing a concept with solar chimneys. What we are doing over here is that every component of the building, as I said before, gets heated up, stores heat inside it. In this, basically, on the left side, again I've shown a rat trap bond wall. Again, it is a semi-hollow inside it. We can allow fresh air to get in from the bottom. This air, since hot air has a normal tendency to rise, it will rise up. You have to give it an outlet to rise up and go out of the building structure. So I can have some solar chimneys connected at the top, have a small pipe outlet made within the wall. Now that will create a natural system of the heat removal. Since hot air, heat is always going to travel up, it will escape. You have to give it a way to escape out of the building. Again, from inside of the building also. The hot air is always trapped at the bottom of the roof. Now you run a fan. What the fan does, instead of basically cooling you up, the hot air which is trapped below the ceiling, it is pushing that down onto you. And it is going on repeating the cycle again and again and again. So you use a air conditioning machine now to remove that heat. Instead, just allow that heat to go away. Just make an opening at the top and let that heat go away. Previously, in all your old buildings, you will see there was a ventilator at the top. Today, the architects have removed the concept of a ventilator. They only put sealed glass over there due to the air conditioning machine. They say the ventilator is not to be opened because the air conditioner won't be effective. In the first case, in case you have an openable ventilator, all that heat would have anyway escaped. So your tonnage and all the heat load would have reduced on the air conditioning. The requirement of the tonnage would have reduced by more than 50% in this case. In the older buildings, you did not require this. The building heights were higher, the hot air used to remain away. Now, due to air conditioning, you design a building, instead of higher heights, you design it for a lower height so that the air to be cooled by the air conditioner is lesser. So the cubicle content of the room you try to reduce. You are going totally reverse of what had been learned over centuries by the old artisans and the knowledgeable people in India, with respect to the Indian climate. They did so many things, but we simply changed them without thinking why. Why were those things happening? So you can remove this air right from above the roof also. You can make a double roof. You can make a double glazed window. You can move air between them, and you can move that also out. The heat won't come inside your building. So these are various ways you can move air through the various parts of the building and from inside the building. And this, again, will not allow the heat to develop inside your building, and you'll be very comfortable. People have talked about geo-exchange. But very few really understand. Geo-exchange has been termed in many ways and used by many people that it is used for so many purposes and all. When we talk about green buildings and all this, we generally talk about people who are making, say, a corporate house or a corporate building or a big building, and not about a single guy who is making a house for himself. So you require solutions for the guy. Even in a corporate building, the CEO is going to go back to his house. He's not going to remain inside the building. Today, Blue Star is advertising, have the air conditioning which you have in your office at your home. So that is the advertisement it is giving over there. So you have to make your own home first comfortable and then other things. Now I've just introduced over here, this is a conceptual thing where I've shown a solar chimney at the top. The solar chimney will allow all the heat to be removed from your building. I've shown another thing which is known as a earth tube air geo-exchange. Now, with respect to the solar, the sun is there throughout the day, but it's not at the night time. The earth is always there with you day and night all the time. As I said, the top layer of the earth becomes an insulator for the lower layers of the earth. Now the lower layers of the earth always remain at a lower temperature than the outside temperature, or at a higher temperature than the outside temperatures during the winters. During the summers, it is at a lower temperature than the outside temperatures. Now you can make an earth tunnel. You can move air through those tunnels. That air comes in contact with the surface of the pipe. The pipe is in contact with the surface of the earth, which cools the air. And that air basically reaches your home, which basically slowly fills up the whole building, and the hot air moves out from the solar chimneys. You will get a very comfortable house in this manner. With a solar chimney or a openable ventilator also, or just a small exhaust fan below your roof, and with a small cooler. Now, what you have done is you have entered the cold air from here and allowed the cold air to go out again at that level only by opening the other window or door from the other side. The real concept is you have to keep your doors, windows all closed. You have to put up a cooler. Now let that cold air come in from the cooler. Give an opening at the top. It might be a ventilator, exhaust fan, or a solar chimney. Now only the hot air will move out from the building and not the cold air. So slowly your whole house will get filled up with cold air. Now just a single cooler with not a 1000-watt fan, just a 250-watt fan, can cool a house of say 3000 to 5000 square feet area. A single cooler can completely cool that much area. Now you are going to consume only just 250 watts. While for doing up a 4,000 square feet area in air conditioning, you are going to use up 25 kilowatts. Not 250 watts, but 25 kilowatts. In this area only, in case you see, you have around 1, 2, 3, 4, 5, 6, 7, 8. 8 air conditioners in just this much area. So going the natural way and understanding how heat and thermals are, you can really make yourself, your life comfortable. Now once you have brought it down from say 25 kilowatts to 250 watts, now I can put up a solar power generator over there. Now it's easy and cheaper to generate 250 watts than to 25 kilowatts. The cost of generating 25 kilowatts is very large. Now the solar panel becomes viable. A common man can now purchase it, use it. So you have to integrate all the thoughts together and use it, not separately. Today the problem has become this, that all fields have become divided. Previously you used to have civil engineering. The civil engineering used to cover up all the things together. Today you have subdivided it into so many segments that one segment does not know what the other segment is teaching or how they are to be correlated. You have to bring all of them now back together. The architect was supposed to bring all of them together, but today the architect also does not go that deep into it. We have been trying to introduce these things since the last 10 years. We have been to consultants, architects, everything. But they are only interested in a certain part which they are interested in doing. Go to an air conditioning guy. He is only interested in doing the whole air conditioning. In case it is not going to be 25 tons, he is not going to own. So he wants to sell that 25 tons and not 1 ton. So he does not want all these concepts. It is only now that in the last 2 years, people have suddenly realized, oh, green building, oh, kya ho raha hai? Platinum rating milegi, gold rating milegi. I want a gold rating for my building. Mr. Gill, can you tell me how? I said, these are simple ways. I'm not trying to sell you things over here. We are not trying to sell you products over here. You have to only change how you think of your building and your environment around, and you can do a lot. Thank you.
Some students have come from Nivai, Dr. K. N. Modi University. Can you please raise your hands? Are they sitting over here? Students from the Dr. K. N. Modi University? Okay. Okay, let's continue with the proceedings.
Agree that an individual should be calculative in his or her approach. The next I would like to call upon is Dr. Jharna Mittal and Professor Rita Bakshi. Next to enlighten us is a keen environmentalist and principal, Professor Rita Bakshi, who has been serving as principal, Ginni Devi Modi Girls PG College, Modinagar, since 1996. She obtained her education in MSc in Biochemistry and PhD in Nutritional Biochemistry from University of Allahabad. She has also served as Secretary Paryavaran Sachetak Samiti. And Srimati Jharna Mittal, who works as a senior lecturer in GDM Girls PG College since the last 9 years. She completed her doctorate from Jawaharlal Nehru University in International Environmental Law. She has successfully completed 2 research projects sponsored by University Grants Commission entitled, I quote, Impact of Climate Change Regime Obligations on Sovereignty of Developing Countries in India, I unquote. Presently, she is working on research project entitled, I quote, An Inquiry into the Legal Principles Applicable in the Indo-Bangladesh Maritime Dispute, I unquote. She has publications in various national journals and has presented papers in national seminars which have been followed by their publication in the seminar proceedings. I request you, ma'am, to please come up.
We have talked since morning about how to save energy, how to minimize the use, how to make use of renewable energy, non-conventional sources of energy. That is all that leads to our efforts to save energy and reduce pollution. However, at a time when we talk everything in terms of globalization, we are also, it's a must to understand which countries are polluting the atmosphere or the world most, and who are putting their best efforts to conserve or to reduce the use of energy. So, as Jharna has a specific knowledge in this field, I'm just passing over to Jharna to spread the knowledge, the information on the international scenario about the usage of energy by the world in various parts and the efforts and what is actually happening in all the international summits, whether it is Copenhagen, whether it is Kyoto, whether it is Rio de Janeiro or Bali summits, what is actually happening in these summits and how the developing countries are being pressurized by the industrialized countries to take over the responsibilities, what damage they are doing and the responsibility being put on the developing countries. Jharna will continue with this.
Thank you, ma'am. A very good afternoon to all the distinguished delegates and my dear students. First of all, I would like to congratulate the organizers of the summit for organizing this endeavor to disseminate information regarding climate change, its various aspects, renewable energy, and sustainable development. Then I would like to appreciate all the speakers who've given so much information on the scientific aspects of renewable energy, and it was very informative and revealing for a person like me who hails from a humanity background.